Let's see this where it is used. Here, while joining dragster to the main leg of a landing gear, it is this small screw is there. This is called Avion. Nothing much special with this Avion, just with its shape or design. It's special with its material. Due to its material which is used and for high strength material is used in this screw. That's why it has its different name as Avion. This one, this and this. Here all these four are Avions. This Avion also not have that threads on it, just a fixed screw. So let's start with this Avion. Today we also make this wheel. So let's start today's session. Start from here we need part design. Yeah. Create body and then create sketch. Let me take front view, that is XZ plane. Okay, this is our intersectionality center. I will take this polyline, this here. This is head of the screw. Then this is leg. We can make it by two methods. First, I may make circle on top edge, extrude it upwards for the head, and then make another circle at the bottom of the head and extrude it as a length. And second way is this. I'm making a cut section of half of the screw, then I will revolve it around this axis, that is that axis, and come up with a screw. Now let's give some dimensions and constraints to it. Okay, this would be horizontal ones and this. Now let's give dimensions. Head radius. Let it be 10 mm radius. Okay, and this radius, let it be 4.5 mm. Okay, so this would be 10 minus 4.5, that is 5.5. Now these are fine enough. Now making this and this horizontal distance 0. This also comes 0. Now the length, let thickness of the head be 3 mm and the length of is 10 mm. Looking fine enough. Let's make this. If I want it center, let it be 10 plus 3, 13, 6.5. Now it is in the center, like this and like this. Okay, fully defined. 3 mm, 10 mm, 5.5 mm, This is also done. 4.5 done. Close it and revolve it. I would like to see isometric so that I can choose success. Z axis 360. Okay. You can see it is not making it and not revolving. Do you know why? Because it's a open sketch. We need a closed figure. So what we'll do, edit this sketch and make a simple straight line joining these 2 points. But how can we know this is joined? Just by coinciding its endpoints. Coincide and coincide. Now it is closed figure. Close. Now I can revolve it around Z axis. Here you can see. Okay. Oh, my mouse is not working. Okay. You can see. This is Avion. If we can see that this length is short, looking shorter than it should be. It's all depend upon the requirements and the other dimensions of other parts. We can also reduce this distance, increase this length, or increase this radius. Anything we can do. The other way which I told was taking top view, making this circle, pad it up to 3 mm, then again taking this space, making this circle and pad it to 10 mm, which we have taken already. Or you can change your dimensions accordingly as per the requirements or with other parts or dimensions. This is done with, we are done with this Avion. No need to change it, or we can change some length here by adding this sketch. Let it be 15 mm and close. Now you can see length has been increased from 10 to 15 mm here. Okay. This is simplest part of the landing gear or anything we could design right now. Here's the Avion, this one, and it is placed here 1, 2, 3, and 4 at 4 places. Just join these different parts to each other. Okay, as this was the simplest part, so I have decided to add up with wheel assembly in this session only, as that was that was also too simple and small part, but a very important part. We can add up with that also. Let me save it. Control S. This save window will open, and here we can save that. Got its name. Avion. Save. Now a new page. Here we have start page. Create new. For that part design is already selected because we are working on it. We haven't opened a new window. When we ever open new window, there it would be this start was already selected by default. So we have to select this part design while making a part. So for that part, create a body, and that body needs a sketch. Now sketch, again I am taking ZX play, let YZ plane for wheel. Okay, here I will make half of the wheel. Let me check this only. Okay, half of the wheel will be I will make, and rest of that will be revolved. Okay, let's start making this wheel. Let me tell you, this wheel has two dimensions. Here it is flat, and this is a little bulge which shows brake assembly. So that's why I'm not saying it is a tire, I'm saying it is a wheel assembly or wheel, because tire and brake assembly are together in it. We are not going to make it different separately, we are making it in a one go. So here I have to make this half part of the wheel, and then it will be revolved around this axis and come up with the whole wheel. So let's start making it. For that, first of all, I need is a straight line. This here, like this, and from here a straight one. Okay, I will make properly by after giving dimensions to it. Let me make them vertical, 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 and that one is horizontal. Okay, here we have a curve. I will choose 3 point curves as I know the end points only, and this is just curvature of the wheel. Let it be like this. Looking fine. We don't need not to do anything else. This we just need to coincide these points. Okay, joining all the points to each other. It is joined, making these coincide. This and this. Okay, now I will give dimensions. Now the shape is fine. Let's take it double like this. Make let it be 10 only. We don't have dimensions, so we are taking just random numbers, whatever it is coming. We are taking dimensions as wait. This one is coming 8.6. Let it be 9 or 21, or let it be only 8 only. That would be much better for us. 8. And distance from this to this vertical distance, we need 20 point. Here, this is not fixed yet. So let me fix this first. This time. So let it be 8 only. We don't need this. So when the original wheel will have these dimensions, this tire, and here is a hub where this brake assembly is attached, and final wheel assembly looks like this only. Okay, now it is free to move like this. Whole wheel is moving. The axle, which whatever axle will make during that main leg, that would be the distance of this, that radius. So for now I am taking whatsoever it is coming. Okay, I need a vertical distance, so I will take this dimensioning part. This will give us a vertical distance. It is coming 4 radius. Let me take 5 so that we can see this distance of this axle hole. 10 total. We have taken 21 is the total radius of the wheel. I am not saying it as n. This now it is moving like this only. We need to fix it also. For that, I am taking this horizontal distance of this point with the center. Let it be 5 as 10 is the total distance. So 5. Now it is symmetric, and still one degree of freedom is left. Let me see which one. This. The radius of this curve hasn't given yet. So let me give this say radius so that it could be fixed. It's coming 6.45. Let it be. We don't need and we don't have exact dimensions, so let it be whatever it is coming. Let us make dimensions a bit clear. Okay, and this. Oh, remember always dimension should be like, it should be clear to have while looking at it. There should no confusion in dimension. Like it should not be like this. We have everything is over there. Here you can't guess what is the dimension of which part. So you need to be very clear about the dimensions. Placement of dimension line is very important while designing. Indicates your knowledge and simplicity. So how simple you place these dimensions and easy to read. Okay, your figure should be cleared. No dimension should mess up with the figure, and no dimension should mess up with other dimension. Now it is very clear that this total radius is 21, this radius is 12, and this length is 8. Total thickness of wheel is 10 Okay, the note to update as I have already on the auto update. If it is not turned on or it is not active, then you after completing your figure you have to update it, and then before closing you have to update it. And now I am closing it. This is our figure. Let us show in isometric view. Okay, so it will be revolve about x-axis, this axis. So it will become out like this. Let me revolve this. Revolve about x-axis like this. Okay, make it zoom to fit so that like this. Here would be the axle of the main landing wheel. Landing leg will be come like this. If I will show you here, this axle will come up in this that hole. Here the bulge which you can see, this is the assembly of brake assembly, and this is wheel of our wheel. And similar shape I have made here with this CAD, so that we can see it from front view. Here is a wheel, and this is our brake assembly bulge, and that axle will come up here with which we have made this hole. Axle will come here. Here you can see. And we have made this brake assembly together in this hole. We didn't make it separately as it has a lot of many different parts and minute parts. It is all a complete assembly with different parts. That's plates and all that around the which parts we are making for our whole landing gear assembly. Around same 10 to 20 parts would be there in the brake assembly only. That's why we have made this like this. Make it like this. Wheel and brake assembly together in one figure. So today we have made two parts, that is Avion and wheel. Avion and wheel. You can wheel or you can also say wheel assembly as brake is also included in this. Brake assembly is not different. If it would be only tire, that is tube tire, not the brake assembly included it, then it would be said as tire. Tire is the rubber part of the wheel which is used to roll on the ground. That's why when your cars or bike, they say tire, we need to change tire. They are not going to change whole assembly of the tire of the wheel. So that's all for today. Here we have wheel as well as avion today. We have completed two topics. Thank you for today, and that's all.
Thank you, sir. Thank you. We can end the session.